In our last class, we discussed about the ionic crystals. There we have came to know about sodium chloride. Then after that we discussed about metallic crystals, copper. And after that we discussed about atomic crystals, that is graphite. That is diamond. Now today we discuss about the structure of graphite. Its features. In graphite, each carbon atom is covalently bonded to three other carbon atoms by a covalent bond, while the fourth valence is free. The lattice of graphite has hexagonal rings which are arranged in layers. Thus graphite has a layered structure. Now when you talk about the hybridization, the carbon atom in graphite is sp2 hybridized. These hybrid orbitals lie in the same plane that are used to form strong sigma bond and three other carbon atoms. Thus the unit cell of graphite has three carbon atoms. Two such unit cell forms a closed packed lattice, and therefore the coordination number of carbon is 3. Next, the unhybridized p orbital, that is left vacant, present on each carbon atom overlaps sidewise to form a highly delocalized pi electron system, due to which graphite is conducting in nature. This pi electron system extends above and below of each layer. And 5. The two layers are held together by weak vulnerable forces which are easy to break. Thus one layer can slip over the other, thus making the graphite a good lubricant. This is the reason why graphite is a good lubricant, because the two layers are held together by weak force and that are easy to break. Thus one layer slips over the other. Since the carbon atoms are held together by strong covalent bond, graphite has a high melting point. Since in graphite the carbon atoms are linked by a strong covalent bond, so it has got high melting point. Graphite is anisotropic for electrical conduction. The conductivity measured along the sheet is high, but across the sheet is poor. This is about the graphite. Next, the last point we have got about graphite has a low density as compared to diamond due to large distance between the two successive layers. The arrangement of carbon atom in each layer causes reflection and absorption of light, and hence graphite is black and shiny. So that was all about graphites. Now we have got the comparison of properties of different types of crystals. How we'll differentiate between these two. Say for example, we have got 4 types: ionic crystals, metallic crystals, atomic or covalent crystals, and the last one is molecular crystals, based on the constituent particles. In ionic crystal, positive and negative ions, whereas in metallic positive ions surrounded by a sea of electrons, neutral atoms in case of atomic, and over here polar or non-polar molecules. Forces: electrostatic force of attraction between you'll find in ionic crystals. Electrostatic force of attraction acting between metallic positive ions and sea of electrons, whereas in atomic or covalent you'll find covalent bond, and in case of molecular you'll find weak polar force. Hardness: hard and brittle in case of ionic crystals, usually hard in metallic crystal, usually very hard in atomic or covalent crystals, and polar molecules are moderately hard and non-polar molecules are soft. Solubility: soluble in polar solvent in case of ionic, and in case of metallic dissolved in solvent by chemical reaction. In case of atomic, insoluble in most solvent. And polar molecules crystals are usually soluble in polar solvent, while non-polar in non-polar solvent. Melting point: high in case of ionic, it is also high in case of metallic, and very high in case of atomic, and low in case of molecular. High in fused state, high, usually low, extremely low. And examples of ionic crystal: sodium chloride, metallic crystal copper, metal, and atomic crystals diamond and graphite. And for molecular crystals we have got ice, polar molecular crystals, solid carbon dioxide. These are the examples.